Can you hear me?
Yeah.
All right. So hi, Carl. Hi, Wicus. Thanks for your time. As discussed, what we wanted to do, or what I wanted to do, was look at this new Shai-Hulud NPM malware, which is a story that's big on the internet right now and is obviously consuming a lot of energy. And we'll talk a little bit about why it's big or how big it is. But really, what I'm interested in as a security practitioner, but not a developer, is to understand some of the kind of developer world elements of it, which I think for some of us are familiar, but maybe not 100% clear. And Wicus, you obviously come from that world. So you were the first person that came to mind. And I wanted to take a little bit of time just to explore the reporting around the issue. We've obviously reported on it to our clients, but I think the most prolific or prominent commentator now are the team from Aikido, and specifically this gentleman, Charlie Erickson, who is clearly very competent and well-informed, and he seems to be kind of leading the charge as far as the analysis of the issue is concerned. All right, so because what I want to do is kind of talk you through the report as it's expressed here, and just get some clarity on some things which, as I say, maybe aren't as clear to everyone as we'd like to believe. And I want to start right at the beginning with this idea of NPM. Explain to me what is NPM? What's it used for? What does it do?
So it's a bundle of code. Basically, it packages code written typically in JavaScript. So it can be run in an environment which is called a Node.js server, which is basically if I recall correctly, a Google V8 runtime, which is Google's created this JavaScript engine, or this scripting engine to do dynamic runtime for environment, typically for JavaScript. But what NPM has created is this whole ecosystem in which you bundle and how you package these programs to be able then to be compiled for a runtime environment, almost, if you will. Typically, if you recall, like some of the work that we've done with that cybercrime, the cybercrime mapper, that site, as you will, when we got it from the developers in raw format, it was just a bunch of HTML and JavaScript and CSS, and it didn't do much in just that native state. But when you run it through this Node.js and NPM workflow, it basically bundles it and stitches it together so that you can then use it in a certain environment, which is typically a Node.js environment, and then just run it. Also, similar to, if you're familiar with how Python works with its modules and so forth, you can also download packages from the Python PyP, for example, store or online repository. Now, NPM is a similar thing. It's evolved into an online repository as well, where people can publish these packages too, similar to Python's environment, and then just you download these dependencies as you will. It becomes also a library ecosystem through which you can reuse other people's code, etc. So it's not just a bundling mechanism, but it's also ability to share code and just capabilities across multiple instances. But I think the whole idea of the NPM has become now a bit larger. It's like a whole ecosystem of which you can get access to things. But yeah, and that's where I think this part of the story is going into, is that ability to just tap into that ecosystem, and then from there you're just a click away from some malicious code. And we've seen many times reporting about these packages being used for malicious activities. But Node and NPM, if you see NPM, Node Package Management, then you basically think of it as a bundle of JavaScript and other supporting meta information that describes it and then is allowed to be downloaded and referenced. And there are version numbers and other dependencies, because some of these packages also use other dependencies. So it's this whole way of just pulling on the string and then everything that's dependent on it getting delivered, making the development environment so much more productive. You don't have to do things as well. So there's a lot of automation that gets baked into this as well.
Okay, so I just want to unpack that a little bit. So Node Package Manager, Node referring to Node.js, which is that right?
Yeah.
It's like a JavaScript library, or the part of a JavaScript library. So the JavaScript ultimately is delivered by a web server to your browser and executes in your browser. So when you say runtime,
not necessarily. No. This is typically made for run on a server. Think of it as if you want to think of it as a Python equivalent, where you write in JavaScript the code, and then this JavaScript code is then compiled in a way that actually can then be executed as a server-based instance, for example, or as an application, like some of the Electron-based applications. Okay. Potentially what we're using in Teams and Slack and all these things. If you've seen, for example, applications that look almost very similar to what you run on the web, but you can also run it on your desktop. Those are typically done in a way that it's bundled using a combination of these cross-platform compile environments. I think Electron is a good example of that, and there are a couple others as well. But they basically allow you to run this app as a very rich browser on its own, but then there's like the dynamic runtime JavaScript elements inside of it as well. Now, okay. Node allows you to do the same. Node.js allows you basically with the Node.js server, you take these packages and you run it actually on your desktop or your server. Most likely it's run as a server. If you think about some of the things we've done in the past with some of our stuff, that runs basically, it's hosted somewhere in the cloud, maybe on a web server somewhere, and as soon as you hit that endpoint, it is waiting for a HTTP request, and based on HTTP request, it basically does stuff. And like you pointed out, it can serve dynamic content through to the browser, then to further execute in the browser as well. But it doesn't necessarily just have to happen in your browser over the web, but it depends on something that can run and interpret the JavaScript code.
Okay. All right. So there's an execution engine that runs on the server,
or and or your machine, but it depends totally on how it's architectured and how it's put together. But just think of it as it can run somewhere. It doesn't have to be on your machine necessarily.
All right. So you're developing code using, would we say, the Node framework to run in this runtime environment, and you want the code, you're going to reuse stuff that's already been written.
Correct. By many
others who are contributing
typically open source.
Completely open source, right? And for that, you need to manage and update all of your dependencies. So you've got a piece of code that does one thing. You want to do something complex like drag and drop a file into an upload, or zoom in or collapse something, or create a visual element, and you don't want to write that from scratch yourself. Exactly. That's complex. So you find a library that does that well. And if we go back to the article, it refers to the earlier versions of this attack, and some components that were impacted. There was a tiny color, I think it was.
I recall something. It was I think that was the Krebs article mentioned that as well.
That was the Krebs article. Yeah.
So those are very popular modules or packages that you find in many projects. But also, I think if I recall it, it's also about an entry point. It was one of the entry points. So if a developer got hit, and that one of those developers on these popular popular modules was successfully compromised, in that it signifies quite a large exposure to potential new victims. And I mean, these modules are all about quality of life as well for developers, where, for example, in Java, it's not a type strict language by design. So certain utility packages could be benign. You don't even see it as a user, as a visual element. It could just be something like, I think it's the ease package or something, that allows you just to do some type checking to make sure you're less likely to cause type confusion, which is the case in JavaScript most of the time. You can quickly get confused, and that can have side effects. So it could be something as simple as a very small little library that gets compromised, and I mean, it just, everybody uses it because it's so popular.
Right. Okay, so I just want to stick with the flow about where this code is executing. So let's assume one of these libraries gets compromised. And by compromised, what we mean there is that the malicious actor can change it, right? So they're actually changing the source of that component, which is then downloaded and embedded into your bundle that you're developing with, right? So you've got a whole lot of libraries, you're working over here. There's all these dependencies that your library is referencing, and those libraries are referencing this whole cascading effect of dependencies, which are doing things that you might understand or might not understand. Now, one of them has been changed, and it can now act maliciously. So from what you said previously, that means that is now executing either in the production environment where this code runs, like on a web server or an application server somewhere, or maybe on some sort of Docker instance, or running on the developer's machine themselves as they code and test, right?
Correct. Or I'm betting that's where you're getting to next. Is there are other ways that this can also be triggered, and that can be triggered just by just download or using a specially designed workflow inside, let's say, some of your development tools, such as Git and all the other supporting tools that you can find, that automates how you download code and how you interact with it at the developer level, which has certain hooks that will then just cascade automatically, because that's how it's designed to work, right? And if there's a malicious element to it, it cascades even faster. But I don't want to get ahead of this. But the point that you're making is there are multiple ways for this to run.
Right. So I think what that then sparks for me is the role of GitHub in all of this, because GitHub features prominently. And I guess one of the things that's not clear to me is you've got the code, the Node.js environment code that is being managed by Node Package Manager. And you mentioned Python. Like if I do a pip install, I'm not referencing GitHub to do that. So what is the role in GitHub in all of this?
From what the reporting shows, it's twofold. It's a way of publishing some of the stolen credentials. There is the pushing of credentials in a like a JSON format to the GitHub repositories. Right. And also what it does is
that's this part here.
Yeah, so basically it exposed that, but it also, interestingly, what I find and very chaotic, to quote the guys from Risky Business, is the fact that it actually makes any private repository on GitHub, it makes public automatically, which means that it exposes something that was not supposed to be, exposed on the cloud service from GitHub. It takes that private repository and it just allows anybody to access it, which is strange in itself, and at the same time it modifies content in those repositories to actually attach to it. So basically, like I alluded to, that GitHub Actions in the webhook, basically as soon as you do certain things in your development environment, specifically with the Git environment, which is your code, what they call software configuration management, also known as code versioning. there are certain actions will automatically get triggered by this, and that's what this worm allows to basically just amplify more of its malicious behavior as well. So it literally allows itself to be successful by using multiple avenues to push through. So the GitHub is a very popular GitHub service is a very popular code repository and just collaboration tool, etc., for how to work between multiple developers as well. Or if you're an open public project, then anybody can just download the code as well. So it's the whole idea of collaborating on a source code level through just this workflows that's embedded in the GitHub ecosystem as well. So two separate ecosystems here. One is for package releasing and publishing on the NPM ecosystem, and then the GitHub environment is to be able to access code changes and code management, as well as other people wanting to make suggestions to changing code or report bugs. So the one is more a pure dev environment and backend and just workflow, and where the NPM is more an ecosystem for just publishing complete runtimes or complete releases. So think of it as a release platform versus a dev platform. So the NPM is more for code that's released as a let's say a ready to run environment, where the dev environment, which is GitHub, is more the staging, as well as the just collaboration and just overall tracking of changes environment.
Okay, let's just pause there. So GitHub is an online service. I know you can run your own versions, and several teams are doing it, but GitHub is now the software as a service owned by Microsoft, I think.
Yes.
And as a developer, what you're doing is you're storing your code there. And then it also allows you to do things like track versions and branch, and then share with others, collaborate, accept, I think what they call commits, which is like updates to your repository.
Pull requests for suggested changes or bug fixes, etc.
Yeah, exactly. Now, a developer, I mean, you can access GitHub obviously via the browser, and you can see the code, and you can copy and paste, or you can download the whole archive of code. But typically a developer has got access to Git sort of automated, right? Either via a terminal using command line Git utilities, or I suppose integrated into an IDE. So as they're coding, they can say commit, and then it does the versioning and all of that. And for that to work, they need credentials, right? And
correct. So if you're the owner of that, or if you're a team member, collaborator on that repository that's hosted on GitHub, then you need to have authentication, a means to authenticate, right? To be able to make changes, especially changes to that, and push what you call it, updates to that, or just delete stuff. In all, authentication is a key component of certain levels of actions.
Okay, right. And those authentications are either those authentication tokens. Now, when it's automated, integrated into your IDE, or running or being accessed by your command line utilities, now it's not a username and password anymore. Now it's typically going to be some kind of authentication token, which is stored then in the developer's environment.
It's cached somewhere.
Cached somewhere, and then just jumping ahead a little bit. Other things are typically going to be cached there too, like access tokens for cloud services, for example, Amazon EC2 API tokens, and I'm guessing these days more and more things like ChatGPT API tokens and things like that the code is going to be calling. Those tokens are now scattered around in configuration files and environment variables and in various places in the developer's environment.
Correct.
Okay, so going back to the NPM thing. So now I'm writing one of these JavaScript applications. I'm using Node. Perhaps even without me knowing it, I install a component because I wanted a little spinning wheel or something. And that starts loading these dependencies, and one or more of these dependencies have now been backdoored effectively, right? Is that
Correct.
that's
So
the
some
essence of the
malicious,
attack?
yeah,
Yeah,
a malicious activity is associated with that one of those dependencies that you knowingly or unknowingly installed. And that's the difficulty here, especially on those what they call that tertiary dependencies or the transitive dependencies. In other words, you explicitly want this dependency, but you don't know what it depends on and the whole chain after that. So literally, like I said, you pull on one string and all these things just get automatically cascaded, downloaded into your environment, and things happen.
Right. So now you deploying or you testing your code. So you've fired up in the Node.js runtime environment. You hit the app with your browser, and these code elements start executing in where your runtime environment is, and they can now access that underlying infrastructure, right? That operating system where
code is executing on that machine.
And it can access the local environment with whatever permissions it has.
Yeah, that user has. And typically, we know users typically run with over-permissioned accounts as well, because they maybe need to do lots of things, and they don't want to be burdened with constant, elevation of privilege checks. So it's already maybe an over-provisioned or over-privileged account that they're running with. These days, you can get away with less privileges as a developer if you use certain workflows and certain, capabilities. But in general, it's freedom. Developers don't like to be locked down too much.
Okay, so then one of the things these malicious elements do is they use this utility called truffle hog.
Correct.
Which then scans the environment that it's executing in, I suppose, with heuristics that allow it to identify things like GitHub authentication tokens and AWS tokens and whatever else.
Correct.
And then that brings us back to the whole GitHub thing. So then it may be that this malicious code then has GitHub credentials, not necessarily in the form of a username and password, but in the form of an authentication token, with which it can then access that developer's various GitHub repositories where code is developed and stored.
Correct.
And shared. And you pointed out that one of the things it does then is to flip a switch that says this repository, which was previously private to me, like your iCloud account might be, now becomes public, which means that other people can visit the GitHub website and see that code, and potentially even modify it. I don't know. Is that an additional permission?
Not necessarily modified. That as a default action, as far as I understand, you need to be added to that project to be able to edit that thing or that tool. But most of the time, you can just access it, like so read only. So the confidentiality aspect, not necessarily integrity or availability is affected, but mostly confidentiality is affected by this action.
Okay, so that's the one thing it does. The other thing it does is it creates this repository with called Shai-Hulud.
Yeah, it just pushes that onto your account. So your account now all of a sudden gets this directory or that repository. Yeah.
And what it then contains is effectively what it managed to harvest from that runtime environment,
the
continuous integration environment, or the developer's PC.
Correct. It's basically a JSON file that's, I think it's like base 64 encoded. And then it literally, like you say, it looks like an environment dump. Like when you say export on your Linux kernel, it dumps all the environment variables. But what this also does, it basically fingerprints the development environment further. The truffle log information's in there that was collected. And it literally says, here's your GitHub token, here's your AWS token, here's the any GCP token, etc. And it just lies there for anybody that you don't even have to do search for. You just you go to GitHub, and in the generic overhead search, you just type in this Shai-Hulud, and then it just like lists all the people's repositories that matches that.
Right.
GitHub. So
So
it's not rocket science to find this, and it's done in a way that's very like difficult to attribute. Because if this information was published only to one location, it becomes quite narrowed down. So this is, like I said, part
right.
of this thing is very chaotic, as if this attacker, was more concerned about OPSEC than actually, to wanted to be quiet and just blend in.
Right. Okay, so that developer's credentials or that continuous integration environment's credentials are now sitting in these repositories spread all over GitHub. I guess GitHub can find them quite quickly and close them down,
Correct.
but there is a window where they're now accessible to the actor, the threat actor themselves, and to anyone else who bothers.
Exactly.
Okay, so that's an exfiltration technique that gets the secrets out.
That's one
But
way
then
of doing
there's
it. Yeah.
yeah, and there's these hooks also, these GitHub action hooks, which we'll come back to, I think, Wicus. But in the meantime, I want to focus on this section now, the self-propagation, because now we go back to NPM, and the analysis is that it republishes itself into other NPM packages. So this developer's downloaded and executed one package, and now part of what it does is described here. So it fetches another package from the NPM registry. So the NPM registry, I guess, is exactly right? It's a registry of what is available within that environment, what's been published, what version number it is, the metadata for those capabilities. Then from that package, which looks like it's packaged up as a tarball, so it pulls that tarball down, it extracts it, and then there's this package.json file, which sounds to me like a kind of metadata.
Exactly. Yeah.
All right, and it changes the version number, and I'm guessing it does that now because that's going to trigger automated activities in other environments where they
Correct.
notice that the version is changed.
Correct.
Is that right?
Because if you use these packages, normally people have rules on, the most basic way of getting these packages. Just give me the latest one. But there are also other workflows that say, I'm within this release hierarchy, I want all the maintenance, or let's say the minor bug fixes. I'm fine with that, but I don't want major. So they restrict the versioning to, let's say, 1.2, but I'm fine with anything within 1.2.x, right?
Right.
But in general, let's say as soon as you bump it to from 0.3 to 0.4, it signifies a new version, and it just automatically then triggers a new download and install of it. So that will then basically ensure that your package, this newly backdoor package, should likely get downloaded much quicker than if you had to wait or use another technique, right? But just bumping the version, it just signifies new version, and people just suck it up.
All right, and then it talks about inserting this life cycle hook for post install, which I'm guessing is then inserted into the package.json, and it expresses something that has to get executed once the package has been updated. Is that correct?
So I'm not 100% sure about where that lifecycle hook sits. It is potentially inside the package.json. I stand to be corrected, but the idea here is with these hooks are on execution of your development tools, likely the Node.js or the NPM environment hooks, or even IDEs that are rich in understanding the actual, let's say, the conditions under which you are operating. There are certain rules and whatnots that they have to follow. Once again, it's to automate things within a development environment. So a lifecycle hook would typically mean that if this flow is happening on publishing, or on doing a compile, or on just running it, if this thing is set, then it is set to do a follow-on action, thus having the ability to create a code execution or doing a follow-on action.
So it kind of ensures that its malicious payload is being executed then upon install.
Correct.
And the install is not ensured, but catalyzed by the update of the version number, which then triggers all these workflows.
It's abusing a legitimate feature of that development environment and runtime environment.
Okay, so then it copies its own payload, which it then adds to the bundle for that npm package. So it sounds to me what it's doing is it's pulling the package down, modifying it with its own malicious payload, and then repackaging it into the zip format, which is then compliant with the npm requirements, I guess.
Correct. So it's basically ensuring that it is then, that's the replication component, right? It's preparing the next version of this compromised environment to contain a copy of itself, which will then be spawned upon being installed or downloaded. So that's where it basically, would you say, that catalyzing that effect of being able to spread again.
But now here it says that it pushes it back to npm using
Correct.
the maintainer's credentials.
Correct.
I don't understand that now, because it's now running on some arbitrary person's development environment, right?
Yeah, I see where you're getting confused here, because there's a subtlety in this reporting, I think, which which probably could have been said differently, especially at the start, where basically the whole process depends on compromising maintainers or developers or people that create packages. It's not, if I was just Joe Soap and I happen to download your package that you created,
you can't just modify it and re-upload it.
I can't do that, right? I would have to what they call fork it under a new project and push it up, but most likely nobody will care.
No one's going to, unless they find it by accident.
You're the main, you're the root of this popular package, and everybody's just pulling from your package. I can't do it as an ordinary person on the internet.
Okay.
What I have to do is I have to compromise you somehow. And if you recall,
that's where the phishing element came from.
Something similar to what happened last week or week before. So it was earlier in August or middle to late August. A similar thing happened with other npm packages, and all they did was they did some Bitcoin. They tried to steal Bitcoin, or not Bitcoin. Let's call it. I think it was wallet or something. They wanted to steal, and they compromised a developer somehow by fooling them using a phishing attack, and credentials were stolen. Anyway, I don't want to confuse it with that thing. I'm not sure if it's related, but very similar thing is I need to compromise you, the developer's environment, somehow, either by fooling you to execute my worm in your environment, or I have to get something on your environment, but I have to get that initial kickstart. That patient zero has to come from somewhere. And if I can hook a very popular package on npm and let this thing rip through there, it's gonna spread like wildfire. And this is what looks like what happened.
Okay, so that answers the next question I had, which is to go back to this comment at the front about a target tarball. So what's actually happening here is this attack started with the phishing, and as I recall the premise of the phishing was something about the multi-factor authentication environment, something needing to be reset or
That was on the previous.
That was from the previous one.
Yeah, on the previous attack about where I think where those attackers only went after like the cryptocurrency wallets and stuff like that. They tricked or they fooled one of the maintainers in saying, well, you have to update your multi-factor authentication token, because otherwise, if you don't, you're going to lose access to your package or whatever. There was a social engineering / phishing element in there with a premise on MFA to get the person to divulge the credentials.
Okay. All right. So so the flow here is that they identify npm developers. I guess we don't know yet which ones they tried, but they would have tried to compromise their credentials in the NPM environment, which is separate to GitHub.
Yeah.
And that's what would have given them
you would hope.
That's what would have given them the target tarballs, right? Because they would have then had those credentials, I suppose, sitting in the malicious payload or available to that malicious payload somehow, so that it can upload more compromised.
What you're saying
NPMs?
is what you're alluding to is correct. So somehow they have to get access to a NPM developer's credentials. And then once they have access to an NPM developer's credentials, they can then act as if they're them. For example, download one of the published packages and then modify and then upload it again and release it onto the NPM platform for further distribution, right? So once you can get those initial credentials, then to infect those people, then you're set to get this worm to really roll. But whether or not how the initial vector happened, I'm not 100% sure. But what if we just repeat or apply ourselves within what what's capable, that's most likely a credential-related compromise that allowed this access and then initially started triggering these worm spreader events, right, if you will.
It's curious to me, because you would think that if the worm has access to these NPM maintainers, has their credentials, you wonder why the worm is then necessary to do the malicious NPM updates. You understand? Like, why go via the worm?
It's to actually get access to other people's environments. So let's say I'm speculating now, I don't know, but let's say this was a generic phishing attempt. It was such an opportunistic action that I happened to get you as Charl, as the developer of this very popular package. Unless it was very targeted, but let's say it's just opportunistic. Right. It happened by luck. The person that got phished, they realized who they were. They might do a spraying attack or whatever. They could realize who they got, right? Somehow they figured out they got a NPM maintainer. I would, if I had to if you had to ask me who do I think it is, this feels to me like a typical Lazarus, like North Korean style. Because the first thing was going after crypto wallets. They like to do that type of stuff, but this typically feels to me like there's some constant MO here going after developers, not necessarily just opportunistic, but if these people knew what they were doing, so they were planning it and they were spearfishing these developers, then they just needed to get one of those maintainers or popular packages, and it just snowballs into other developers' environments, which snowballs in other developers.
And some of those other developers are also going to be NPM maintainers.
It's possible, and then
right.
If they let's say they're not, but they're developers. They've got a GitHub account, and let's see if they got any other cloud keys, AWS, right. GCP. Now all of a sudden you get access to those dev environments or those maybe pre-production environments, and if right. it was properly segregated. But let's say you're a small little company and you're just gunning for getting in MVP out there, then you probably only have one deployment environment because cloud can be expensive. So the whole idea is you just want to snowball so you can get access to as many cloud environments potentially. I would think that they were trying to get to cloud environments for deployment environments and to pivot into something else, potentially cryptocurrency cloud environments or crypto exchange environments. That would just be a jackpot if you could get into one of those big cryptocurrency exchanges.
Okay, so if I just reflect this back to in my own naive words, so what we're seeing is a supply chain attack on a set of NPM libraries, which was achieved via compromising those developers' credentials, probably with phishing, but okay, we don't know that for the purposes of this conversation.
Yes.
So then they're backdooring those NPM libraries with this malicious payload. The malicious payload triggers on the developer's environment or in the continuous integration environment or in production. That backdoor dependency triggers, it then runs the truffle, what is it called? Something
Truffle hog.
Truffle hog to just slurp up anything that looks like it could be a credential for anything else.
Yeah, or a
Then
token.
uses, including GitHub, then
Yeah.
uses the GitHub authentication token to dump all of that where it's publicly possible, where it's publicly available to both them and everyone else. Also, for some reason, changes the repositories to public. Not clear why. Maybe there's more credentials in those repositories. I don't know.
I would bet that's a good chance there could be people, because people sometimes accidentally include environment runtime sensitive information in there as well.
All right, and then there's the worm component, where if that developer is also a maintainer within npm, those npm packages are then backdoored in the same way, and this lifecycle trigger is inserted so that when that package is installed, it triggers, and so that is that the worm then snowballs without any user interaction being required.
Exactly. That's the key.
Then that's kind of then the third component. So there's the credentials, GitHub, other cloud environments, and then the self-propagating component through the npm environment. And one of the things I read, which I thought was interesting, is, of course, they're saying the speed of propagation appears to have been slowing down, which is, I think, you would expect. But of course, it just has to sit there, right? It just has to sit there until one day somebody picks it up again, and if it's the right person, it triggers again, and that then brings me to this concept of worms, because actually those self-propagating worms are not that common, certainly not in kind of the modern era of cybersecurity. And we were saying the sort of most obvious one that comes to mind is the Sammy Kamkar MySpace worm.
That I love you, wasn't it? What is it?
Sammy is my hero.
Oh, Sammy's my hero. Yeah, that one. Yeah.
So, Carl, you were looking at some of those. What's your feeling about like where this kind of self-propagating worm sits in the family tree of worms?
There's a pretty long history. Like you say, you mentioned the Sammy MySpace. There's Mirai, WannaCry, NotPetya, Conficker was especially prevalent. As you said, though, recently it's not really been seen that much. It seemed to fizzle out, I think.
And we were talking the other day about what was that term? So I've got a terrible memory. Authorization sprawl. Is that the term that's being used? Is this kind of behavior, is it enabled by that idea of kind of tokens being stored here to access that, and then stored there to access that other thing?
Absolutely. It's the fact that people think tokens are different from passwords. I've typed in my username and password. I got this very long string, and this very long string of characters is now used to authenticate me every time I make this API call, which is just a pseudo version of your username and password. However, there is lifecycle management around that string, or that authorization key. And for one, those values should actually be stored in a very safe and secure place.
Like in a TPM. Like a separate, TPM, some sort of separate hardware
TPM,
platform or something. But they're not. They're in configuration files and environment variables and
sitting somewhere in clear text
code. Yeah. All right. In the interest of time, I know all of us have got somewhere else to be, and I'm sure people don't want to listen to us for too long. I want to ask one last question, going all the way back to the phishing via MFA. And one of the things that I see thrown around is that people should be using phishing resistant MFA. Carl, it occurred to me that I'm actually not sure that I know what they mean when they say phishing resistant MFA. What is the definition of that term? Is that like not SMS based, or via a third independent channel? Is that
To be honest, I'm not 100% sure. I would assume that it's potentially referring to the use of a authentication app, which only the authorized user has access to. As you say, SMS can be intercepted. It's not a strong method for MFA. But other than that, I'm not sure of the exact definition of phishing.
SMS is vulnerable to SIM swaps, and I guess when it's like a token-based thing, you have to put that token into a web form again. Where I suppose it's vulnerable to being, man in the middle or attacker in the middle.
Yeah.
So what is
the passkeys are, if you look at passkeys, the original use case of passkeys are actually for that. These YubiKeys, Python from Google, those integrated with your browser serve actually as quite a good means to be resistant to phishing, because typo squatting and these lookalike domains can also trick you sometimes. And if they proxy through that, then you typically get these evil Nginx type of man in the middle, attacker in the middle style attacks where they proxy through it and you can still get fooled. But when you use a passkey, the passkey and the browser work together to ensure that the enrolled credentials are fixating on the original enrollment domain. So in other words, I can't be fooled by lookalike or person in the middle style attack or attacker in the middle style, because the passkey will not accept the authentication along with the browser, because the browser looks at the certificates and look at the domain name, and then with the credentials that's, I wouldn't say burnt, but is baked into your FIDO-based web authentication. The two don't match, so the authentication cannot continue, especially on the hardware token. So those passkeys, the hardware passkeys, typically are resistant to those type of phishing style attacks. It's still possible with your apps, especially if even though if it's a push-based attack or whatever, it can technically still be there can still be somebody in the middle. But with a hardware token, it's less likely to occur. It requires so much more attacks, chaining of attacks. You at least, as I understand it, you have to compromise the CA to be able to get to that level, or find a way to fool the browser to be able to accept the domain as something else that's being presented. But the attack surface becomes considerably more complex, and for your typical phishing, it's just not worth it. So those are the ones I suspect they're referring to.
Okay, and that's the trajectory is towards passkeys, and
and I would also say
anything that involves a username and a password.
There's going to also become other, I would say hurdles, but developers are going to have to stage their work. So in other words, you push it into a let's say pre-acceptance section of your workflow. Then you log into let's say you go into the staging environment. Let's say, like, take this workflow of this worm. They would take their changes, push it up, although they've already Trojanized this thing. They push it up, and before that thing can then be released to the mainstream, somebody has to go in and click release, and then you would use, let's say, your passkey to authenticate, to show all the, you're present, you control the key, your identity is there, and it was a physical action. It's not an automated action. So that I would say, human in the loop is becoming overused right now, but somebody physically took action to release that, right? And if you don't know why that thing is sitting there, then you should ask yourself, like, how did it get here? So these gated releases are going to become much more important, and especially if you look at people citing the S-bomb type of thing, where the software bill of materials type of thing, pulling down any package these days must also be gated, where you can't just pull the latest package down. You're going to have to go, like, literally curate everything and say, why am I pulling this thing down? Approve it, push it into the dev environment, and everybody pull from the dev environment, cached environment. So everything's going to get gated. Yeah, it'll be gated at any point. Automated, as much as everybody's saying automation, automation is a total, like, it'll blow your foot off if you had to do that type of thing going forward. Everything's going to go back to stricter gated procedure and workflows and authentication at each critical decision point.
All right. Okay.
Guys, I think that's all we're going to have time for. I feel like we can have this conversation much longer, but I think you certainly answered my fundamental basic questions, which is what I was hoping to get out of this. So thanks for your time, and if anyone does listen to this, thanks for yours. We hope it was useful. Cheers, gents. Thank you.
Yeah, bye-bye.
Thanks. Bye.